Scientists studying Jupiter have noticed something unusual happening to its most famous feature. The Great Red Spot, a massive storm that has been raging for centuries, is changing. Observations from NASA spacecraft and ground-based telescopes show that the storm is shrinking, becoming more circular, and behaving in ways that researchers did not expect. The Great Red Spot is not just any storm. It is the largest and longest-lasting storm ever observed in the solar system. It has been continuously tracked since at least the 1830s, and possibly even earlier, based on historical observations from the 1600s. At its largest, the storm was big enough to fit 3 Earths side by side. Today, it has shrunk significantly and is now about 16,000 kilometers wide, which is still large enough to swallow Earth, but much smaller than it used to be. Scientists have been tracking this change for more than a century. In the late 1800s, the Great Red Spot measured over 30,000 kilometers across. Since then, it has steadily decreased in size. To understand what is happening, researchers have been studying the storm in more detail than ever before. One of the most important sources of data comes from NASA's Juno spacecraft, which has been orbiting Jupiter since 2016. Juno revealed that the Great Red Spot is not just a surface feature. It extends deep into Jupiter's atmosphere, reaching depths of about 300 to 500 kilometers. That makes it more like a massive atmospheric structure than a simple storm. At the same time, scientists noticed something unexpected at the edges of the storm. Portions of the outer cloud layers appear to be breaking off. This process, sometimes called flaking, involves pieces of red material peeling away from the storm and drifting into the surrounding atmosphere. This raised an important question. Is the Great Red Spot slowly disappearing? The answer is not so simple. Even though the storm is shrinking, it remains extremely powerful. Wind speeds inside the Great Red Spot can still reach up to 430 to 680 kilometers per hour. That makes it far stronger than any hurricane on Earth. Researchers believe that interactions with nearby smaller storms may play a key role in its behavior. These smaller vortices can either feed energy into the Great Red Spot or disrupt its outer structure, causing parts of it to break away. In other words, the storm may be losing size, but not necessarily losing strength. Another unusual feature is its color. The Great Red Spot has changed in appearance over time, sometimes becoming darker and more intense, and at other times fading to a lighter orange. Scientists think this color is caused by chemical reactions involving sunlight, ammonia, and other compounds in Jupiter's upper atmosphere. Changes in these chemical processes could explain why the storm's color varies over time. There is also growing evidence that storms on Jupiter are not permanent. Observations show that large atmospheric features can form, evolve, and eventually disappear. This suggests that even the Great Red Spot may not last forever. Some models indicate that if the current trend continues, the storm could keep shrinking over the coming decades. However, predicting its future is difficult because Jupiter's atmosphere is extremely complex. The planet is covered in powerful jet streams that circle it at high speeds. These jet streams help stabilize large storms, but they can also stretch and reshape them over time. Recent data shows that Jupiter's atmosphere is layered and dynamic, with multiple storm systems interacting at different depths. This makes it difficult to determine whether the changes we are seeing are part of a long-term decline or just a temporary phase. What is clear is that the Great Red Spot is not as stable as scientists once believed. Even a storm that has lasted for centuries can change. NASA and other space agencies continue to monitor Jupiter closely using spacecraft and telescopes. Each new observation helps scientists better understand how extreme weather systems behave on gas giant planets. For now, the Great Red Spot is still there, still active. and still one of the most recognizable features in the solar system. But the changes we are seeing suggest that even the largest and longest-lasting storms can evolve. And one of the most iconic features on Jupiter may be slowly entering a new phase.
A few years ago, NASA caught a mysterious green glow on Jupiter. It was moving at breakneck speed and almost escaped detection. Could it be proof that Jupiter has secrets we've been missing for decades? And if so, how will it affect us humans on Earth? Well, the truth is, astronomers didn't just stumble across this phenomenon. They've been studying Jupiter very carefully for a long time. The reason is the Juno mission. The Juno spacecraft was launched in 2011, and it reached Jupiter in 2016. Since then, it's been orbiting the planet and collecting tons of data. Juno's job is to help us understand what Jupiter is made of, how its atmosphere works, and what's happening deep inside the planet. In 2020, one of Juno's cameras, called JunoCam, clever, captured something strange. Near Jupiter's North Pole, a bright green flash of light occurred. This light appeared to be moving very fast. Capturing fast-moving objects in space is extremely difficult. That's why this image surprised many scientists. So, what could this green glow be? The most plausible and widely accepted explanation is lightning. But lightning on Jupiter is very different from lightning on Earth. On Jupiter, lightning forms inside massive clouds made of ammonia and water. These storms are far stronger than anything we experience here, and they can produce unusual colors, including green. But what if the green glow isn't lightning at all? Why didn't we see it before? This glow could always exist, but it probably moved too fast for our cameras to catch until now. Anyway, if we spot it again, we would be able to study it more closely and figure out what's really going on. Until then, a lot of the explanations are still educated guesses. Another question is what this might mean for Earth. Scientists are sure it won't have any direct impact on our planet. But the discovery is still important. It shows that weather-like phenomena such as lightning exists on other planets, and sometimes in much more extreme forms. Like on Mars, for example. Scientists have just discovered that the planet's atmosphere crackles with static electricity. In other words, Mars has tiny lightning. Back in 2021, when a dust devil rolled over NASA's Perseverance rover, scientists expected to hear the usual stuff: sand scraping, wind rushing past. Instead, the rover picked up a faint pop. At first, it didn't make much sense, and now, researchers finally think they know what it was. That sound likely came from electricity discharging in Mars's thin air. Basically, mini lightning on Mars. It doesn't look like lightning on Earth. There are no bright flashes streaking across the sky. Mars's atmosphere is too thin for that. Instead, these are tiny sparks. Still, they count as lightning, which officially makes Mars the third planet beyond Earth known to have lightning, after Jupiter and Saturn. How did scientists find this? Well, Perseverance has a microphone called SuperCam mounted on its mast. Over 2 years, it recorded about 28 hours of Martian sound, and hidden in all that audio were 55 short bursts that matched what you would expect from small electrical discharges. The sparks were super tiny, like those little shocks you get when you touch a doorknob after walking across a carpet. Yeah. Each spark lasted only milliseconds, but 7 of them also lined up with electromagnetic interference. This is a big clue that electricity had jumped through the air near the rover. But where does this Martian lightning come from? On Earth, lightning forms inside storm clouds when ice particles collide. Now Mars doesn't have rainstorms like that. It's too cold and dry, but it does have a lot of dust. When strong winds whip dust grains around, they rub into each other and trade electric charges. Scientists use a long and complicated word to describe this phenomenon: triboelectrification. But the idea is simple. Friction builds up electricity. Once that charge grows strong enough, it releases. That release creates both sound and electromagnetic waves, the very signals Perseverance detected. These tiny sparks might sound harmless, but they matter a lot. Electrical activity can change Mars's chemistry. It may help create reactive chemicals like hydrogen peroxide and percolates, which break down organic matter. That could help explain why Mars struggles to preserve signs of ancient life. Electricity might also affect how dust moves. Charged dust lifts more easily, which could help dust storms grow and support themselves. That creates something like a feedback loop. More dust, more charge, more storms. And there's a practical side too. These sparks won't hurt astronauts directly, but they could interfere with electronics or damage sensitive equipment. Knowing when and where they happen will help engineers design future missions and future spacesuits to handle Mars's electrically active environment. Now, let's move further away from the Sun. Here's something that might change how you picture the solar system. New simulations suggest that Uranus and Neptune might not be giant balls of ice after all. They could actually be much rockier on the inside, with thin icy layers around. Researchers at the University of Zurich ran new models and found that these ice giants don't have to be ice-dominated to match what we observe. In fact, many of their simulations work just as well if these planets contained a lot more rock than expected. Based on the data we have today, Uranus and Neptune could be rock-heavy or ice-heavy. There's just not enough information to choose between the two. That's why scientists keep calling for missions that would orbit these planets and study them up close. Voyager 2 flew past Uranus in 1986 and Neptune in 1989. It grabbed a few measurements and kept going. No spacecraft has ever stayed long enough to really figure out what's happening beneath the clouds. So scientists rely on computer models built from limited clues. The classic ice giant picture still works, but it's no longer the only explanation that fits the data. Now, another astonishing discovery involves Uranus's moon, Ariel. Even though it's small, scientists now think it could have once hidden a massive underground ocean that made up more than half of its entire volume. That ocean could have been around 105 miles thick, and it might have existed as recently as 1 billion years ago. Ariel is only about 720 miles wide, roughly a third the size of Earth's moon. Because of that, scientists used to assume it couldn't hold on to heat for very long. Newer research doesn't quite agree. When Voyager 2 flew past Uranus in 1986, it sent back images showing that Ariel's surface didn't look old and frozen. Instead, the moon looked relatively young and active, with cracks, ridges, and even signs of ice volcanoes. Some of those features look surprisingly similar to what we see on moons, like Europa, Enceladus, and Triton. And those are places we already know have oceans beneath the ice. Later on, scientists also found traces of ammonia and carbon-based compounds on Ariel's surface. Those chemicals usually don't last long, unless something keeps bringing them up from below, which often means liquid water underground. Researchers built models of what the inside of Ariel might look like. In their simulations, the moon had a brittle outer crust, a softer layer underneath, a deep ocean below that, and a solid core at the center. After that, they tested how Ariel's crust would react to tidal forces, the constant stretching and squeezing caused by Uranus and nearby moons. It turns out that if Ariel's crust was less than about 19 miles thick, it would crack under a serious amount of tidal stress. One source of that stress could be an interaction with another moon, Miranda, about 1 to 2 billion years ago. That interaction slightly stretched Ariel's orbit and put enough strain on the crust to break it. In any case, it's too early to claim that Ariel still has a huge ocean today. It's small, and it loses heat easily. If any liquid water remains, it's probably much thinner and not exactly a great place to look for life. Hey, what do you say we light a giant match on Jupiter, the largest room of explosive gas in our solar system? Jupiter has methane, a gas that's famous for its bright burning. Plus, there's metallic hydrogen, which, under the planet's extreme pressures, turns into a potent fuel. However, when we try to start a fire, nothing happens. There are no expected explosions. Now why is that? And can we fix that if we really want to blow up Jupiter? Jupiter is the titan of our solar system, the biggest planet we have nearby. It's 11 times wider than us. If Earth was a nickel, Jupiter would be a basketball. It's hanging out as the fifth one from the Sun, right after Mars. It's also more than 300 times heavier than our Earth, and twice as heavy as all the other planets combined. Because of this enormous mass, it acts as a moon magnet. Jupiter has 95 known moons. The most famous of them are the Galilean satellites, Io, Europa, Ganymede, and Callisto. They were discovered by Galileo Galilei in 1610. Jupiter also has some rings. Now, they're not as fancy as Saturn's though. Just faint rings made of dust, not ice. Because of that, they don't reflect light as brightly, and we can't see them with a naked eye. Jupiter also has the shortest day in our solar system, only about 10 hours. But it takes the planet about 12 Earth years to go around the Sun one time. But the most important thing about the planet is that, unlike Earth, it's not solid. Jupiter, as well as Saturn, are the so-called gas giants, planets made mostly of gases. Gas giants are mainly composed of hydrogen and helium, the same stuff that makes up stars. Jupiter and Saturn also have a dash of other heavier elements. This doesn't mean that the entire planet is just a ball of gas. The pressures inside are so harsh that molecules can't stay in that form. Their outer layers are made of compressed molecular hydrogen. As we dive deeper, it turns into a layer of liquid metallic hydrogen. Finally, there's a potential rocky core deep down. From the outside perspective, it looks like layers of clouds in their atmospheres. Jupiter also has these stripes and swirls that look like patterns. Now, in reality, they're chilly clouds made of ammonia and water, floating in a mix of hydrogen and helium. Its famous Great Red Spot is actually a massive storm that's been raging for hundreds of years. This storm itself is bigger than our whole Earth, and it's twice as fast as the Earth's fastest possible storms. So this is the problem we encounter when we try to light a fire on Jupiter. If you somehow manage to stand on Jupiter without any solid surface, while not caring about the titanic gravity and the crazy storms, fire needs oxygen to burn, and Jupiter's atmosphere doesn't have any. No oxygen, no flames. Well, let's assume that we have a magic match that can generate its own oxygen. That should work, right? Well, unfortunately, Jupiter is so massive that you would need an insane amount of oxygen to do that. Perhaps way more than the entire solar system has. You might have heard that Jupiter protects us from dangerous asteroids. It's so gravitationally strong that it attracts all the objects that could have hit Earth otherwise. In general, Jupiter experiences from 30 to 100 collisions per year. Well, these meteorites falling on Jupiter didn't cause explosions either. Even the most powerful crash on Jupiter didn't. It happened with a comet called Shoemaker-Levy 9 in 1994. The comet broke into pieces in 92, some as big as half a mile. And then, in 94, it got a little too close to Jupiter. The impact was incredibly dramatic. Over 6 days, 21 fragments hurtled into Jupiter's atmosphere at great speeds. The planet's atmosphere heated up to 53,000 degrees Fahrenheit. Like a ripple effect from a tossed rock into a pond, the impacts created colossal plumes. They reached up to 1,900 miles above Jupiter's clouds. Dark clouds of impact debris scarred Jupiter's atmosphere for months, gradually fading away in the planet's winds. Now, this impact told us a lot of interesting things about Jupiter. For example, the dark impact clouds acted as wind tracers and revealed high-altitude winds in Jupiter's stratosphere. Changes in Jupiter's aurora helped us learn more about the planet's magnetosphere. And finally, it provided insights into Jupiter's chemistry. Comet Shoemaker-Levy 9 sparked NASA's interest in addressing the risks of impacts like that on Earth. This, in turn, helped us to learn more about comets and impacts in general. Saturn, the sixth planet from the Sun and the second largest in our solar system, is also a gas giant. Like Jupiter, it's not just a plain ball of gas. Even though it's mostly made of hydrogen and helium, at Saturn's center there's a dense core of metals like iron and nickel surrounded by rock. What's interesting is that it's much lighter than Jupiter. It's only 95 times heavier than Earth. Saturn has stripes in yellow, white, reddish, orange, pink, and green. Who came up with that color palette? Winds in the upper atmosphere can reach a staggering 1,090 miles per hour, even faster than on Jupiter and unimaginable compared to Earth. They look like colorful belts covering the planet, finishing with fascinating rings. Now, these rings are made up of bits and bobs from comets, asteroids, and shattered moons. There's even a Cassini division, a gap that separates some of these ring layers. Now, what about Uranus and Neptune? They're also giants, and for a while, scientists believed that they belong to the same family as Jupiter and Saturn. However, after a while, we discovered that they belong to a different category, ice giants. Again, they're not some giant ice cubes floating in space. Instead, they're mostly made up of heavier substances like water, ammonia, and methane, which could freeze into icy layers in their atmospheres. This is what sets Uranus and Neptune apart from gas giants, despite sharing some similar traits, like awful storms. Our solar system isn't the only one that has planets like that. There are also extrasolar gas giants, categorized by their atmospheric properties from ammonia clouds to entirely cloudless. For example, there are hot Jupiters, a separate category for, well, very hot Jupiter-like planets. They're gas giants that settle too close to their stars. For example, Kelt 9b and Kepler 7b are so close to their suns that 1 year on them lasts just 18 hours. Recently, we also discovered a little hot Jupiter. This planet, called HIP 67522b, is only a few million years old. Sounds like a lot, but it's nothing on a cosmic scale. Our own moon is about 4.5 billion years old. Now, this discovery challenges the norm. Most hot Jupiters out there are a way over 1 billion years old. We're still not sure how this one formed so quickly. What's even more interesting is how these hot Jupiters end up so close to their stars in the first place. Theories abound. Some say they formed right there, despite scorching conditions. Others believe they ventured in from outer space. For example, icy materials made together in a drifting rogue planet. And when it passed around the star, it got attracted by gravity and stayed in orbit. Maybe it happened early on, when the star was wrapped in a gas and dust cocoon. Or later. Scientists will need more research to say for sure. There are also weird oddballs. No, not me. Gas dwarfs. They're also called mini-Neptunes. They're smaller versions of gas giants that have rocky cores swaddled in thick hydrogen and helium blankets. They're called after Neptunes because, after being a bit smaller than this planet, they share a lot of similar traits. Their size ranges from about 2 to 4 Earths. Usually, it's a world with a hefty atmosphere, mainly filled with hydrogen and helium, and perhaps layers of ice, rock, and even liquid oceans beneath the surface. If a planet like that didn't have much gas in its wardrobe, we'd call it an ocean planet instead. We're not sure why they exist, and they defy some scientific norms. Like hot Jupiters, these planets require more exploration.
Hey space buffs, just how well do you know our solar system? Guess the planet. It's more than twice as massive as all the other planets combined. It's covered with striking swirls and stripes, which are actually windy clouds of cold ammonia and water, floating in an atmosphere of hydrogen and helium. Still no clue? Then look at this. It's the infamous Great Red Spot, a giant storm larger than our home planet that has been raging for hundreds of years. Right you are. This cloudy world is Jupiter, and the main question is this planet our enemy or friend? NASA's Juno orbiter is exploring this gas giant at the moment, sending us tons of useful data. Jupiter is so big that 11 Earths could fit across its equator. If our planet was the size of a grape, Jupiter would be a basketball. The gas giant is the 5th planet from the Sun, orbiting around 484 million miles away. And even though for us Earthlings, our blue-green world seems to be the most important among all the other planets, we live in Jupiter's solar system. After all, it accounts for 75% of the mass of all the planets in our star system. And it's also 318 times more massive than Earth. And whatever Jupiter wants, Jupiter gets. Jupiter wants to throw stuff across the solar system? No problem. After all, this gas giant doesn't have its immense gravity for nothing. It yanks material from the asteroid belt, stopping poor space rocks from forming anything larger than Ceres, the only dwarf planet located in the inner solar system. Jupiter is hungry, it gobbles up comets, asteroids, and whatnot. Jupiter's bored. It hurdles everything it manages to capture on wayward trajectories. This gas giant must have caused a lot of destruction over the course of its life, which is around 4.5 billion years. But here's the thing. Some scientists think that we might owe our very existence and the existence of our planet to Jupiter's protective gravity. It may sound confusing, but by greedily swallowing up dangerous space objects, this planet vacuums the solar system. Other astronomers don't agree with this theory. They claim Jupiter is a hooligan, bothering peaceful and safe comets and sending them to unexpected places. You see, some of the most dangerous objects in our solar system are long-period comets. Those are huge chunks of ice and rock coming from the depths of the Oort cloud, which lies far beyond Pluto. Some of them get pushed into the inner solar system, where they dash past the Sun. There's a chance that the most devastating extinction on Earth was caused by a long-period comet. As such comets make their way through the solar system, they likely interact with Jupiter's gravity. The gas giant pushes them this way and that, consuming some of them like delicious ice rock burgers. But does Jupiter push such comets out of their dangerous orbit so that they don't smash into Earth? Or does this gas giant actually divert the trajectories of the comets that would otherwise miss Earth? No one knows. Astronomers sometimes call Jupiter a failed star. The gas giant indeed contains a lot of helium and hydrogen, the material stars are mostly made of. But the planet's mass isn't enough to start a fusion reaction in its core, and that's exactly how stars produce energy. They fuse the atoms of hydrogen together under extreme pressure and heat and create helium. In the process, they also release light and heat. Jupiter could start a nuclear reaction and become a star only if it was 75 times its current mass. Paradoxically, if Jupiter even got more massive, it would also get smaller. This additional mass would make the planet denser, and it would cause the gas giant to start pulling it in on itself. Astronomers are almost sure that even if Jupiter was 4 times its current mass, it would still remain the same size. Jupiter has between 80 and 95 moons, but one of the most popular ones these days is Europa. Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. That's what Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system, looks like. And the coolest thing about this faraway place, it might host life. Astronomers consider Europa to be one of the most promising places in the solar system to search for new forms of life. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it's still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. For a long time, scientists have been wondering about Jupiter's X-ray auroras. What causes them? It seems like the 40-year-old mystery has been solved. Jupiter's breathtaking X-ray auroral emissions are triggered by electrically charged particles called ions. They crash into the gas giant's atmosphere, and here's the result. But astronomers couldn't understand how those ions got to the atmosphere in the first place. But recently, they've seen the ions surfing Jupiter's magnetic field all the way down to the planet's atmosphere. Astronomers have received this data thanks to NASA's Juno spacecraft and ESA's XMM Newton telescope, situated in Earth's orbit. Now, on our home planet, auroras are only visible in a belt surrounding the magnetic poles, between 65 and 80 degrees latitude. Anything beyond 80 degrees and auroras disappear. But Jupiter's X-ray auroras are much more inconsistent. They pulsate regularly poleward of the main belt, and sometimes they're different at the north and south poles. Scientists have figured out that this pulsation is caused by the fluctuations in Jupiter's magnetic field. You see, when the planet rotates, it drags behind its magnetic field. Struck by the particles of the solar wind, it gets compressed. This heats the particles trapped in Jupiter's magnetic field, and they start moving along the magnetic field lines, producing magnificent auroras. Another feature Jupiter is famous for is its Great Red Spot, an enormous storm raging in the southern hemisphere of the gas giant. Its top parts tower more than 5 miles above the surrounding cloud tops. The storm is more than twice as wide as our planet. At the edges of the storm, the wind speeds reach 270 to 420 miles per hour. That's faster than Earth's tornadoes. The hot gases in the planet's atmosphere are always moving, rising, falling, and swirling. Just like on our planet, when cooler and hotter gases mix and merge into one another, they form giant circling storms. Astronomers think that once several enormous storms could have come together, creating the Great Red Spot. And now it keeps raging by constantly drawing cool gases from below and hot gases from above. Plus, this monster of a storm absorbs other, smaller vortices. They make the spot even more powerful. Several theories try to explain why the storm has its trademark color. It varies from whitish and pale salmon to orange and brick red. Some scientists believe the answer lies below the Great Red Spot, closer to the planet's surface. A colorless layer of ammonium hydrosulfide might be reacting with the cosmic rays or the UV radiation coming from the sun. This somehow gives the spot its pretty red color, but so far, it's just a theory. Astronomers have been observing the Great Red Spot since the 1830s. And for the first time, the storm was spotted in 1665 and described as the permanent spot. In other words, the storm is almost 400 years old. Strangely, it's been shrinking in size since the beginning of the 21st century. In 2019, it began flaking at the edges, with small pieces breaking off and vanishing. If this process continues, by 2040, the Great Red Spot might become circular, or it may simply disappear.
Imagine leaving your house one morning and seeing not one, but 2 stars shining in the sky. The first one is our good old sun, and the other is Jupiter. But how has a planet turned into a star? And what will now happen to Earth and its inhabitants? Before we find the answer to these urgent questions, we need to revise some things we know about Jupiter. The largest planet in the solar system is a gas giant, which means it's made up mostly of gases. Due to the pressure and temperature differences, these gases separate into layers. This creates those red and white bands that can be clearly seen from Earth. The temperatures at the top of Jupiter's atmosphere are insane. They can reach a whopping 1,340 degrees Fahrenheit. The planet also has an immense gravitational pull. In 1995, the Galileo probe reached the atmosphere of Jupiter and sliced it at a speed of 106,000 miles per hour. It survived the scorching temperatures and started its descent. It kept moving even when the temperature suddenly dropped and the pressure, as well as the speed of the wind, increased. But 58 minutes and 97 miles into its exploration, things went downhill. The pressure of 23 atmospheres and still high temperatures finished the probe off. It was melted and then vaporized by the extreme heat. Now, if Jupiter suddenly decided to keep growing, it would eventually become a star, and its composition would allow this planet to do it. Once, a long time ago, Jupiter took most of the mass that was left after the formation of our Sun. That's how it ended up with more than twice the combined material of all other bodies in the solar system. And the planet's ingredients are the same as those of a star, mostly hydrogen and helium. Jupiter is just not massive enough to ignite. But what if it was? Then it would turn into another kind of celestial body, most likely a brown dwarf. In this case, it would have a minor effect on the orbits of the planets of our solar system, because brown dwarfs are more massive than planets, but not as massive as stars. A brown dwarf is usually 13 to 80 times the mass of Jupiter. It can only become a star if the pressure in its core gets high enough to start nuclear fusion. So let's imagine that it's happened, and Jupiter has become a real star. For example, a red dwarf. Red dwarfs are stars with masses around 7.5% to 50% of the mass of our Sun. Red dwarfs are also hotter than brown dwarfs. Their temperature can reach 6,380 degrees Fahrenheit. Our Sun, by comparison, has a temperature of almost 10,000 degrees Fahrenheit. So, it means that the newly formed red dwarf will be far dimmer than the Sun. And still, red dwarf Jupiter could prevent the inner planets from following their orbits, because they wouldn't be able to find a balance between the gravitational forces of the two stars. The planets would move either closer to the Sun or closer to the newly formed red dwarf. If Earth chose the first option, our main star's insane temperatures would probably wipe all living beings off the face of the Earth in no time. If it was the second scenario, we'd probably freeze, since Jupiter, as a dim red dwarf, wouldn't be able to warm us up well enough. But there could be one more option. The inner planets could get thrown out of the solar system altogether. If Jupiter was a star, it would also greatly increase the amount of radiation the surface of Earth would receive. Our atmosphere would have to protect us both from the radiation coming from the Sun and from Jupiter's radiation. Red dwarfs are notoriously active. That's why Jupiter, just like the Sun, would most likely have frequent coronal mass ejections. This is a fancy expression for describing large clouds of electrically charged particles a star releases with a huge burst of speed. Even now, Jupiter has a significant impact on our planet. The gas giant is roughly 318 times as massive as Earth. And this also means it has an outsized pull on our planet. Its gravity can cause shifts in the orbit of our planet and climate swings every 400,000 years or so. When Jupiter's influence is the strongest, Earth usually has colder winters, hotter summers, and more intense periods of wetness and droughts. Also, if Jupiter turned into a red dwarf, its most prominent feature might probably disappear for good. I'm talking about the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts tower more than 5 miles above the tops of the surrounding clouds. The storm is almost twice as wide as our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot, and it turned out that this monster of a storm went more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere. And keep in mind that Jupiter's temperatures are negative 280 degrees Fahrenheit in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, The highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. They were higher than the temperature of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating. But the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear altogether. But that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The wind speed at the edges of the storm can reach a mind-boggling 400 miles per hour. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. And now, I have another what-if situation for you. What if Jupiter collided with the smallest star we know about? Today, these two space bodies are on a collision course. A spoiler, Earth might not survive such an encounter. Okay, meet this tiny red dwarf. It's the size of Saturn, and its gravity is around 300 times the gravity of our planet. It normally floats 600 light-years away from Earth in a double star system. But today, for some inexplicable reason, it's broken all the laws of the universe and is rushing toward the biggest gas giant in our solar system. And even though this space guest is smaller than Jupiter, its mass is way greater, and its gravitational force soon starts to pull on the gas giant. The heat from the red dwarf, plus its powerful gravity, makes Jupiter grow in size. The planet's atmosphere starts to puff up because the gases that make up the planet begin to heat up and expand. Jupiter's atmosphere starts to leak into space toward the stellar visitor. Sometime later, the runaway gases form a bright hot ring around the red dwarf. This is a terrifying view, as if a black hole, a very bright one, has appeared inside the solar system. The star keeps tearing Jupiter apart, eating chunks of the gas giant, and soon the red dwarf engulfs it completely. Sadly, Jupiter never stood a chance. Instead of the gas giant, we now have a red dwarf surrounded by a ring of hot gases. And we already know how badly it may end. The best thing about it is that this scenario is totally imaginary. Phew, thank goodness.
Uh-oh, hurricane alert! Everyone's hiding! The speed of the wind outside is more than 75 miles per hour. Seems like a lot, but this storm is moving at 400 miles per hour. Wait, do such speeds exist? Yep, but to see a storm that fast, you'll have to travel to Jupiter. So let the journey begin. The planet is huge. Almost 1,300 Earths could fit into this gas giant. It's also incredibly hot, with the temperatures reaching about 43,000 degrees Fahrenheit at the planet's core. Unfortunately, you can't land on Jupiter's surface because, well, being a gas giant, it doesn't have any solid surface. But you can go deeper into Jupiter's atmosphere. Look at these thick brown, yellow, red, and white clouds passing by. They're what make the planet look colorful and kind of striped. If you continue descending toward the center of the planet, you'll see its atmosphere, mostly made up of hydrogen and helium gas, becoming liquid. It happens because of immense atmospheric pressure. The planet's core itself is a mysterious object. Scientists still haven't figured out whether it's a molten ball of thick liquid or a solid rock 14 to 18 times the mass of Earth. Anyway, exploring Jupiter isn't the main goal of your trip. No, you've arrived here to see the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts are towering more than 5 miles above the tops of the surrounding clouds. The storm is 1.3 times wider than our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot. And it turned out that this monster of a storm goes more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere, and keep in mind that Jupiter's temperatures are minus 234 degrees Fahrenheit in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. There, the heat reached 2,400 degrees. This temperature is higher than that of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating, but the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear entirely, but that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The change in the wind speed is no more than 1.5 miles per hour during one Earth year. It's a tiny change, but however small the difference is, it still means a lot. The wind speed at the edges of the storm can reach a mind-boggling 400 miles per hour. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. Scientists faced lots of challenges when they were trying to understand the mystery that was the Great Red Spot. It's unclear what fuels the storm. Can it be the nature of the storm's home planet? Since it's a gas giant, Jupiter doesn't have any solid ground, so there's no friction, which might be the only thing that could make the storm weaken. The hot gases in the planet's atmosphere are always moving, rising, falling, swirling, just like on our home planet, where cooler and warmer air mix and merge into one another, forming giant circling storms. Astronomers think that once, several enormous storms could have come together and created the Great Red Spot. And now, it keeps going by constantly drawing cool gases from below and hot gases from above. Plus, the storm might be absorbing other smaller vortices. This makes the Great Red Spot even more powerful. Unfortunately, thick clouds on Jupiter don't allow astronomers to see what's going on in the planet's lower atmosphere. Scientists have been speculating on what may hide beneath the Great Red Spot for decades. Is it a massive volcano? Unlikely. Jupiter is mostly made up of gases, and it doesn't have a crust that could crack, letting lava escape from the planet's interior. There are also a few theories explaining why the storm has its trademark color. It varies from whitish and pale salmon to bright orange and brick red. Some scientists believe the answer lies deep below the Great Red Spot, closer to the planet's surface. A colorless layer of gas might be reacting to the UV radiation coming from the sun. This is probably what gives the storm its red color. But so far, it's just a theory. Hey, your guess is as good as mine, huh? Jupiter isn't the only planet that can boast having a giant storm. Another one, as wide as our home planet, rages on Saturn. It's called the Great White Spot. How clever! The storm has a tail of white clouds encircling the entire planet. It occurs every 30 years or so. The storm indeed starts as a spot, but then it starts stretching and stretching. Astronomers have figured out that the Great White Spot is actually a huge system of thunderstorms. At the top of the storm, lightning can flash more than 10 times per second. But the main mystery about the Great White Spot is where it gets its energy from. Some scientists think it may be powered by the sun. Others argue that the storm's cloud pattern only makes sense if there's an internal source of heat that can power the winds. Anyway, severe storms on different planets of the solar system aren't the only space mystery that makes astronomers scratch their heads. Let's move to Pluto, the largest known dwarf planet in the solar system, and explore its atmosphere. It rises really high above the surface of the planet and has more than 20 layers, all of them freezing cold and extremely condensed. By the way, our moon also has some sort of an atmosphere. Called an exosphere, it consists of helium, neon, and argon. It's 10 trillion times less dense than Earth's atmosphere. While traveling through space, watch out for black holes. Woo! A black hole is a place where gravity is so strong that even light can't get out. But black holes can sometimes behave like a massive galactic volcano. From time to time, they flare up. Sounds like me. But instead of spewing lava, they produce enormous amounts of energy. And this phenomenon leaves gaping holes in the surrounding material and gas. A short while ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater this event left behind could fit 15 Milky Way galaxies. Yeah, I can't get my head around that either. During your space voyage, think twice before landing on unknown planets. Otherwise, you may end up in a place like K2 141b. That's a planet outside of our solar system. At first glance, it's not that different from Earth. It has liquid oceans that evaporate, form clouds, condense, and get back to the surface as rain. But instead of water, it rains rocks. The surface of this exoplanet is covered with lava seas dozens of miles deep. The temperatures on the K2 141b reach 5,000 degrees during the day. That's toasty enough for the magma in the oceans to vaporize into the atmosphere. Then, supersonic winds, which can move at the speed of 1 mile per second, carry this rock vapor into the planet's night side. The vaporized magma cools down, becomes liquid again, and falls as a rocky rain. Not a vacation spot. Too hot. I'll pass. Extremely hot and insanely fast. Yeah, that's me. Oh wait, you mean the space thing. Okay, first, they discovered Peg 51, an exoplanet that orbits a star similar to ours. An exoplanet is any planet outside of our solar system that orbits a star that's not the Sun. This planet was completely different from anything we've ever found. Almost the same diameter as Jupiter, but half the gas giant's mass. It took only 4 days for this exoplanet to orbit its star, which seemed impossible. It was definitely too fast for something so massive. And then, scientists started finding something they've named hot Jupiters all over space. Lots of heated gas giants were located only a couple of million miles away from their stars. Sometimes, there were a couple of space bodies orbiting their stars pretty closely, and many were a few times bigger than Earth. Solar systems where they found hot Jupiters are not like ours. We have a neat system with smaller rocky planets on the inside and big gas giants on the outside. And almost all of them peacefully orbit the Sun, following their trajectories. Everything is in order. When a star is at the earliest stage of its formation, it creates a disk of gases, debris, and dust surrounding it. It's called an accretion disk. These gases slowly get pulled into the star because of its gravitational forces, and this leads to some kind of a stellar whirlpool. The outer parts of the disk are more gas-dense than the center. With time, the whirlpool effect gets even stronger. The same thing happens with hot Jupiters, which causes these gas giants to start orbiting much faster than usual. This also carries it further toward the star in a tightening spiral. Luckily, our Jupiter didn't become a hot Jupiter. Our gas giant started its life as an icy Earth-sized asteroid, which is different from the way hot Jupiters form. During the time when it was forming, Jupiter was around 4 times as far from the Sun as it is today, somewhere between Uranus and Neptune. About 2 to 3 million years after Jupiter first formed in the accretion disk of our Sun, it started a 700 million year long phase astronomers call the Grand Tack. Now, tack is something a boat performs when going towards a buoy and then slipping past and around it. Then it speeds up and goes in the direction where it came from. That was the same thing Jupiter started doing, and in its tightening orbital migrations, the planet's gravity could have moved many asteroids and other space bodies, distorted the orbits of larger planets, and caused collisions and chaos. Jupiter's grand tack would have destroyed many big space bodies. It's a could-have-been scenario, but luckily, Jupiter changed its course and became a peaceful gas giant. Neptune, Uranus, and Saturn were starting their own version of this chaotic process. Saturn even got so big that its gravity started pulling Jupiter away from its orbit. But after some time, these gas giants' orbits became locked. Then both of them managed to clear away the gases remaining between them. And since these gases were some sort of fuel for the planet's migrations, Jupiter and Saturn could both finally settle into the stable orbits we know today. Jupiter can still lob 1 to 2 icy asteroids at the inner planets from time to time. But when our planet was younger, this could have been one of the processes that formed the oceans on Earth. But Jupiter is much calmer these days. Saturn's gravitational forces have moderated the situation and are now keeping it under control. Now, Jupiter is our protector. It's 2.5 times the mass of the other planets of our solar system combined. It's some sort of a gravitational shield orbiting around the inner part of the solar system. Jupiter redirects incoming debris and asteroids away from the inner planets, Mercury, Venus, Earth, and Mars, keeping us all safe. Because of this, Earth has always been protected, so our planet has had enough time to evolve complex life forms. And it hasn't been destroyed by asteroids, hot Jupiters, or other space bodies. Jupiter wasn't the only planet that could have collided with Earth. Scientists think Mercury might have been involved in a hit-and-run accident with our planet. Mercury is the innermost planet in our solar system. It's the closest to the Sun and the smallest planet out there. And it also keeps getting smaller. Nowadays, its diameter is around 9 miles smaller compared to its size 4 billion years ago. Scientists think this might be happening because the planet's core is made of iron, and this iron is cooling and becoming solid, which is slowly reducing the planet's size. Mercury is the planet with the biggest number of craters in our solar system. Its atmosphere is really thin, so it can do nothing to keep the planet protected from meteors. The largest crater on Mercury's surface is at least 963 miles across. It could fit Western Europe from Germany to Portugal. The object that formed such a crater must have been at least 62 miles long. With all these craters, Mercury looks similar to our Moon. It orbits the Sun faster than the other planets, so 1 year on Mercury lasts around 88 Earth days. That means celebrating a birthday every 3 months or even more often. At the same time, the planet rotates so slowly that a day on Mercury lasts almost 59 Earth days, a long time to wait to go to bed. There's a piece of Mercury on our planet. In 2012, a green meteorite was found at a street market in Morocco. Scientists studied its composition and concluded it could be from Mercury. Mercury doesn't have its own moons because of its small size and weak gravity. Plus, the planet is too close to the Sun. By the way, the only other planet without moons in our solar system is Venus. Mercury has a really thin crust, like a good pizza. One of the theories of the planet's formation claims there was a major collision where the planet lost most of its crust. It could have also moved Mercury from its original spot. It wouldn't be unusual. The gas giants in our solar system also didn't form in the location where they are today. Mercury also has an eccentric orbit, which means it could have been kicked out of its old orbit and moved to a new one. Scientists also think Mercury might have collided with the early Earth. One theory says that's how the Moon could be formed. Out of all the material flying away after the big crash, there might even have been pieces of Mercury's crust in the mix. Exoplanets Kepler 107b and Kepler 107c are a pair of planets that orbit a star similar to our Sun in the Kepler 107 system. It's around 1,700 light-years away from us. These planets have almost identical sizes, both with a radius 1.5 times that of Earth. But one of them, Kepler 107c, is almost 3 times as dense as the other. That's because the planets have a different composition. Some scientists believe that Kepler 107b is less dense because it probably collided with another unknown planet in the past. This powerful hit took away part of its surface and left behind a very dense core rich in iron. A huge comet hit Neptune around 200 years ago. But since Neptune isn't a rocky planet with a thin atmosphere like Mars or Mercury, it's harder to find evidence of this impact. But a comet called Shoemaker-Levy 9 broke apart in 1994 and smashed into Jupiter. Astronomers managed to record this event. It helped them learn more about the elements and molecules the collisions left in Jupiter's atmosphere. This information helped scientists realize that the amount of carbon monoxide in the upper layers of Neptune's atmosphere is higher than in the lower ones. This means a big comet likely hit the planet in the past, since comets have carbon monoxide in their icy tails. Something huge slammed into Uranus, too, changing the planet forever. A space object twice bigger than Earth hit the ice giant. This left the planet tilted, and it looks as if it's rotating on its side. Uranus is extremely cold, way colder than it's supposed to be. It might mean that the object that slammed into it was probably a young protoplanet made up of ice and rocks. Also, some of the debris from that collision may have created a thin shell around Uranus. It still traps the heat coming from the core of the planet. There are strange energy pulses bombarding our entire galaxy, and they come from the other side of the universe. Over the last decade, scientists have been observing bizarre flashes of light coming toward our planet. This phenomenon is called fast radio bursts, or FRBs. These signals travel through a couple of billion light-years of dust and gas. That's a rather long way. So far, no one has figured out what's going on behind these bursts. Bang! Another hit on Jupiter. Let's see. Gas giant, the largest planet in the solar system, 318 times bigger than the Earth, 2.5 times bigger than the rest of the planets in the solar system put together. One more interesting thing. If it got any bigger, it would actually become smaller. You see, with more mass, the planet would be denser. That would cause Jupiter to start pulling in on itself. Scientists say Jupiter could have 4 times greater mass, but still keep the same size. It takes 10 hours to make a full rotation on its axis. It's the fastest spinning planet in our solar system and gets hit by so many space objects all the time. This was discovered by amateur astronomers observing Jupiter and saw some unusual flash at the planet's surface. Impact events cause flashes like that, and for some reason, Jupiter gets more impacts than other planets. In 1994, astronomers discovered Shoemaker-Levy 9, a comet that broke apart and collided with the gas giant. The original comet was approximately the size of one that erased the dinosaurs. However, this asteroid fell apart into more than 20 fragments. They darkened the planet's surface, and it remained like that for months. 15 years later, in 2009, astronomers saw a black spot on Jupiter, the size of Earth. It was the result of an asteroid around 650 to 1,650 feet in length. The biggest asteroid recorded on Earth hit the area of Tunguska, Russia in 1908. This caused a massive explosion, even though no one ever found a crater. So, why is Jupiter the target for so many space objects? Asteroids and comets that pass by Earth and Jupiter go almost at the same speed. The number density of the space object that may interact is almost the same too. But the cross-section of what they might hit is very different. Jupiter has 11 times the diameter of our planet, which means it has around 125 times the cross-section. The more massive some planet is, the stronger its gravitational attraction. So, it will entice some space objects drifting by. Our gravitational field is weaker than Jupiter's. If some object passes near us moving at a speed of 22,300 miles per hour or less, our gravitation will attract it. Asteroids and comets usually move at bigger speeds. Jupiter attracts most of the comets and asteroids passing by. If our planet was hit by such big objects as frequently as Jupiter, we'd have extinction like with dinosaurs thousands of times more often. In 2020, scientists found there was an unusual asteroid in the orbit of Venus, the first one there. The size of a small mountain and rich in minerals we can find in Earth's deep rocks. They even think it could be a clue to a bigger set of asteroids created when our solar system was forming. That's not the only mystery around Venus. The planet has insanely violent winds that drive clouds and storms around the planet at speeds greater than 220 miles per hour. That's 60 times faster than Venus itself rotates. Also, scientists are still not sure what happened with its oceans. They believe since the planet is so close to the sun, the water evaporated and went into the atmosphere as steam. It trapped heat coming from the sun, heat that would have vaporized more and more water over time. Venus probably had an environment like on Earth, but a very long time ago. The theory says many comets and asteroids were slamming into Venus. Billions of the planet's pieces were flying all around. Some may have even crashed into Earth's moon. Pieces that slammed into our planet are probably buried very deep, since we have greater geological activity than the moon. Uranus also had a collision, but a more serious one than asteroids. The rest of the planets in our solar system mostly have an axis of rotation that kind of points up from the elliptical plane. Uranus is tilted, lying on the side, so a season there lasts 42 years, when either its south or the North Pole is pointed at the Sun. Most of the planets also rotate counterclockwise when you see them from above our solar system. Venus does the opposite, which means maybe it was kicked off axis a long time ago. Uranus may have collided with the other space body millions of years ago. When our solar system was still very young, the orbital configuration of Saturn and Jupiter may have crossed. Their gravitational forces kind of created orbital momentum and transferred it to Uranus. That knocked it off axis. Millions of asteroids orbit the Sun, and not so many pass by Earth from time to time, so we don't have some dangerous space bodies coming toward us. The plan is to visit Mars in the 2030s, and scientists hope Mars won't be a target of some bigger space bodies. New craters are formed on the red planet every 1 to 2 days. They can be 13 feet across, which means they could have been formed by objects that are the size of a soccer ball. Since the atmosphere there is thinner than ours, smaller bodies can enter easier. Most of the Martian north is smooth lowlands. The south is higher, full of craters, and the planet's interior has a surprising amount of rare metals. The theory says this is because a big celestial body collided with Mars and tore away a part of its northern half. Debris from that asteroid circled the planet and then mixed into 2 small moons that orbit Mars. We also have some Mars rocks on Earth, found in the Sahara Desert, Antarctica, and some other places across the globe. Some of these rocks have gas that's chemically the same as the atmosphere on Mars. Rocks probably came due to a big explosion that happened when some larger asteroid or meteor that was ejected from Mars and landed on our planet. Mercury also has a thin atmosphere, so there are many smaller strikes there. Imagine waking up, going to your window, and see there are micrometeor showers every morning, which is something that happens on Mercury. This strange weather pattern shapes its atmosphere, called an exosphere. Mercury is so dense, its heavy iron core accounts for 2/3 of its total mass. Scientists think it could have been bigger in the past, but many collisions got the surface sort of scraped off. It's been constantly bombarded by rocks from space that left marks with craters. Plains on its surface seem to have been created because of volcanic lava spilling over the surface and then dried smooth. Many craters are filled with such a material, which means there's one more thing that rocked Mercury's world: volcanoes. There's an unusual group of asteroids discovered near Neptune, wide range in sizes from big metropolitan areas to tiny pebbles. They are thought to come from an asteroid group called the Kuiper Belt. It makes a ring well beyond Neptune. But these new asteroids have different colors than the Kuiper Belt. They're so far away from the Sun, their surface was supposed to stay almost pristine, but they have a similar color to those sun-baked asteroids around Jupiter. Like the rest of the planets, Neptune gets heat from the Sun. But there's something mysterious inside the planet that makes it generate more heat than it gets. This affects its weather, and Neptune has the weirdest weather in the whole solar system. Massive storms, insanely high winds, cirrus-like clouds that rapidly change all the time. There are dark spots in its atmosphere. They come and go. We receive 1,000 times more sunlight than Neptune. Gas giants like Saturn and Jupiter can protect our planet from asteroids. Without them, the big impacts that created enough debris to form both moons and other planets would happen more often. There's a huge asteroid going around Saturn, which could be a potential flyby by 2031, more than 10 times bigger than the asteroid that erased the dinosaurs. Titan, one of the moons orbiting Saturn, 80% more massive than our moon, is actually the only moon in our solar system that has an atmosphere. It's 1.5 times thicker than ours and consists mainly of nitrogen, like our atmosphere. No one knows where all that nitrogen came from. However, unlike Saturn and most of the other places in our solar system, its moon has a real potential to host life.